If someone told you that they needed a new system to order, for example, Minnesota Gopher football tickets, would you know where to begin? We need a process to bring these systems to life, and that process is sometimes generally referred to as the Systems Development Lifecycle, or SDLC. In this video, we'll introduce the SDLC, and after this video, you'll be able to describe the phases of the Systems Development Lifecycle, as well as its history, and we'll also talk a little bit about how the SDLC fits into organizational cultures. Specifically, you'll be able to describe how the organization provides context for the SDLC and list the characteristics of a process-oriented organization. But first, let's take a look at the SDLC itself. Now, it's important to understand that there are a lot of varieties of the systems development lifecycle. Each and every organization often has their own systems development lifecycle. The reference SDLC that we will use for this course has 4 phases: plan, analyze, design, and implement. In essentially this course, we will walk through these phases. In this first module, we're taking a look at plan phase, and we'll dig deeper into plan phase in the next few lessons. In the next module, we'll take a look at analyze phase, and we'll look at analysis phase documentation. In the third module, we'll look at analysis phase diagrams. And then in our fourth and final module, we'll look at design phase and talk briefly about implement phase. The business analyst, which is the role that we're focusing on, does most of his or her work in the analyze or analysis phase. And so that's why we'll have a heavy focus there. The input into this process is some sort of idea or opportunity, or you could say an inefficient process that we start with. We run this process through the SDLC, and out the other end comes a much more efficient technology-enabled process. The SDLC itself has evolved over the history of computers use in business itself. Before 1985 or so, the process was essentially ad hoc, meaning that there was no real defined process. The success of your information systems implementation often depended on the experience and the talent of your employees. As information systems became more popular, however, we began to develop a formal methodology for bringing these systems to life. That methodology is what we now know today as waterfall methodology, and we'll talk about the characteristics of that in a minute. Since then, starting in the 90s, waterfall methodology evolved in response to a changing business environment and the need for more dynamic and agile processes. And then today, agile methods are some of the most popular methods around, and we'll explore agile methods in depth in a future video. The basic SDLC that we're using for reference in this course is a 4-phase waterfall model. Some important characteristics of the waterfall model are that we have very well-defined phases and cutoffs with artifacts, in other words, documents, that denote the end of each phase and the transition into the next phase. We don't have very much iteration between phases, and as we'll see later, this is one of the major critiques of waterfall, that it's very inflexible. If the whole SDLC takes, for example, 18 to 24 months, basically a 1.5 to 2 years to run, there's a good chance that the business environment and the organization will change during that time, and waterfall is not particularly responsive to those changes. And then finally, plan phase, the assumption that plan phase produces a complete project plan is often a flawed one. We often don't have all the information that we need up front. If we examine the waterfall methodology in depth, there are 2 common misconceptions that I want to address right up front. The first is, when do we do the programming? This would typically happen in what you see on your screen as the last phase, or the implement phase, where you see program and install software. The other big misconception is around purchasing software off the shelf. So you might, for example, want to do a systems improvement project. For example, you want to automate your point of sale system in a small business. And you might decide that you're going to purchase an already available app to do this automation. Well, in the waterfall model, in the SDLC that we're using for this course, the decision to purchase that software would actually happen during the design phase. And students are often confused by this. They say, well, if I'm just going to kind of purchase software off the shelf, do I need to do the SDLC? My usual response is, how do you know if the software will meet your needs if you haven't taken the time to do the analysis? And so therefore, this choice of buying or building often happens in the design phase, and that's something we'll explore in a future module. The success of the waterfall approach often depends on the organizational environment in which it's being implemented. We're going to look at two categories of companies. The first are traditional hierarchical companies where you might have a functional manager, for example, that oversees a team of business analysts or a team of software developers. The second category is more of a process-oriented organization, and I would argue that waterfall is likely to be more successful in organizations that have a rich process organization history. What you see on the screen is a context diagram, and we've seen a context diagram before, but this is a meta-context diagram in a sense. It represents a calculator development process at a company called TI, or Texas Instruments, and many of us might remember the old TI graphing calculators that we used in math class. They implemented a cross-functional process to develop these calculators, and it was designed to get input from teachers as well as feedback from the manufacturing sites on the feasibility of different designs. And that process ultimately failed within TI's organization. The reason for this failure is just likely because TI had a very traditional kind of hierarchical functional organization rather than a process management or oriented organization. So how can we recognize whether we work for a more process-oriented organization or a more functionally oriented organization? Well, you might notice some indicators in the vocabulary of the people that you work with or the vocabulary of the organization itself. For example, instead of having unit goals, you might have process goals if you're part of a more process-oriented organization. Employees, instead of being trained on tasks, might be trained on processes. Instead of saying my unit, you might say my process or the process that I'm a part of, and so on. These organizations became increasingly popular for a while, and in general, development processes like waterfall tend to be more successful in these organizations. However, there are some downsides. Career paths are not as obvious to employees as they are in traditional functional organizations where employees can climb a more obvious ladder. And then process standardization is often enforced even when it doesn't fit. And what this means is we often try to take a process from one area of the company and implement it in another area of the company without regard for whether or not that's appropriate. And so each type of organization has its own kind of pros and cons, so to speak. However, these more rigid software development processes tend to be more successful in a more process-oriented organization. In a process-oriented organization, a process owner owns each process. We usually use something called a decision rights matrix to clearly identify the roles between the functional manager, who manages the employees, and the process owner, who owns the process itself. Process standardization does not imply that all business units should use the same process, and this is something that process-oriented organizations often struggle with, is trying to force-fit those processes into areas where they might not apply. The shift from a traditional environment to a process-oriented environment cannot happen quickly. This is a major change that must take place over time. In future videos, we'll dig into the SDLC and look at some of the variants of the SDLC that have become increasingly popular in today's more rapidly changing business environment. The waterfall methodology is our reference methodology, so to speak. It's what every information systems professional learns when you go to school. However, the waterfall methodology is rarely put into practice exactly as is. Instead, we put into practice a more modern variant of the methodology itself. In this video, we'll take a look at what some of those variants are, as well as popular vocabulary in the space these days. After this video, you'll be able to list the major variants of the SDLC, compare and contrast rapid application development with waterfall, as well as describe the relationship between waterfall and agile, and perhaps most importantly, you'll be able to identify the methodology or combination of methodologies used in your organization. Let's start with a little bit of history that we introduced in the last video. We discussed the fact that before 1985, most systems development projects were kind of ad hoc and relied a lot on the talent and capabilities of your developers. We started to formalize this into waterfall methodology in the mid-'80s. And as a review, the characteristics that indicate waterfall methodology are a set of rigidly defined or clearly defined phases with deliverables that move between each of those phases. So for example, in this slide, you've got your project plan that transitions us from plan to analyze, and then the system proposal, which transitions us from analyze to design. Now, what are some things that we can do to kind of spice up, or you sometimes see the term supercharge waterfall? Well, three things that we'll discuss are, first, the use of prototypes. Prototypes are essentially building a version of the product that allows people to experiment with the product, but it's not necessarily production ready. When we dig deeper into analysis phase, we'll talk about how we use prototypes as an analysis tool. We use prototypes to put them in front of users to elicit what their requirements might be. Another thing we can add into waterfall to kind of supercharge it, so to speak, is electronic tools. These are sometimes called case tools for computer-aided software engineering. Specifically, there is a family of standards called UML, which is represented on the slide here. And UML stands for the Unified Modeling Language, which is essentially a standardized language used for modeling information systems. Now, when we get to design phase in our final module in this course, we'll talk a little bit more in depth about UML tools as well as the different UML products that might be helpful in design phase. The third thing that we could do that would kind of enhance or supercharge waterfall, so to speak, is the introduction of something called joint application development, so JAD sessions. Joint application development sessions are sessions that are held between users and software information systems and software development professionals, and they're used to elicit requirements from the users in a very collaborative manner. There are a lot of methodologies out there for implementing these JAD sessions. For the purposes of this course, we bring it up solely for the purposes of awareness, and if you want, there are additional readings that allow you to dig into this topic a little bit further. So we move from a waterfall methodology to a supercharged waterfall by adding in enhancements such as prototypes, joint application development sessions, and case tools or computer-aided software engineering tools. If we want to move to something that's more radically different, then we might move on to a methodology sometimes referred to as RAD, or Rapid Application Development. RAD is a family of methodologies that introduce the concept of iteration into the SDLC. Specifically, with a RAD-type methodology, we often build a part of the system and then we put it in front of users so that they can interact with the system and provide feedback. We then use that feedback to further refine and enhance the system, and then we put it in front of the users for feedback again. We continue this cycle until we feel like we have something that we're ready to introduce, or for a predefined number of iterations. Iteration is the primary characteristic that indicates RAD methodology. However, there are other cycles of iteration that can be introduced as well. So, after we introduce the system, for example, we might go back and do versions 2, 3, and 4 of the system, and so on. So we take a pause from our internal iterative cycle to introduce the system, and then we move back to identify objectives, information requirements, and begin work on version 2. And then the cycle continues to version 3, version 4, adding functionality at each version along the way. And you're probably familiar with this from many of your commercial software products such as Windows or Microsoft Office. The textbook that we use for this course actually illustrates this slightly differently and quite well. You can see that the planning and analysis phases are conducted at the front, and this maps roughly to the identify objectives and information requirements you see on the slide. And then we go through a series of intermediate iterations that represent the kind of intermediate versions of the product, introducing the system at the end of each complete cycle of iterations. So RAD introduces iteration into waterfall methodology. Now we turn our attention towards a major buzzword in software and information systems today, and that's the concept of agile methodologies. We still teach waterfall because in order to understand agile, you need to understand waterfall first. You need to understand, in a sense, where we've come from to understand why agile is important and popular today. Waterfall has a lot of rigidity to it. It's often referred to as a traditional methodology, and for that matter, add in the supercharged waterfall and even the RAD that we've just talked about into the family of traditional methods. We then have agile methods that emerged in the late 90s, became popular in the 2000s, and are widely used today. These kind of methodologies add in a number of vocabulary, but what I'm hopeful that you'll see when we're done with this video is that you'll see that it's based on a lot of the same principles that waterfall is based on. Let's first talk about what agile is. Some consider agile to be revolutionary. In principle, agile focuses much more on values than it does on process and methodology. So on the left, you have some snippets of what's called the Agile Manifesto. These favor individuals and interactions over processes and tools, working software over documentation, responding to change over following a plan. And so you can see the idea here is that Agile is trying to address some of the rigidity and some of the shortcomings of traditional waterfall methodologies. Now, is Agile truly revolutionary? And what are the key differentiators between waterfall and agile with respect to their core practices with resources, activities, and values? Well, I would argue not a whole lot. They take a lot of the same things that we do in waterfall methodologies, we rename them, and we often do them on shorter timescales. So we might move through, for example, a waterfall methodology within the span of a week or 2 weeks, instead of doing so over the course of 18 to 24 months. Agile has its own set of phases, and again, most of this is just vocabulary, so we go through an envisioning phase, we speculate about how the system might work, then we move into our delivery phase where we iteratively deliver features. A key part of Agile is monitoring and adapting, as and we do this on short time cycles, and then finally closing the project. Some things that you'll see associated with Agile is the concept of a sprint, which typically occurs in the span of a few weeks, and that's iteratively adding features, and then the idea of a backlog, which is prioritized on a regular basis. And those are essentially the features that users find most important. And so a lot of this is kind of putting a new vocabulary. We have user stories instead of requirements. We have a sprint instead of a phase, and so on the traditional vocabulary. We begin with envisioning, then we might speculate. We then iteratively deliver features, monitor and adapt, and then finally we close out the project. This is another example of an agile life cycle, and you'll see a lot of the same vocabulary used here. And so in many cases it's essentially the same, but just with a slightly different vocabulary attached to it. Now, in summary, why is all of this information important? Well, it turns out that the different methodologies are well suited to different types of projects and different types of organizations. And so in the end, it's not a matter of Agile necessarily being better than Waterfall. It's just better than Waterfall at some things. For example, when you have unclear and changing requirements, Agile adapts to that very, very well. Waterfall, on the other hand, requires that you know most of your requirements up front. On the other hand, Agile typically has what we call poor process visibility. This means that upper management doesn't often get as much visibility into the project, the timeline, for example, how far along we are and when it will be done, as we do with a more traditional process like waterfall. The other area where Agile is still kind of finding its place, so to speak, is in highly regulated environments. For example, FDA regulates the environment for medical devices, and Agile processes don't often meet the documentation requirements of a regulatory body like the FDA. And so you'll still find a lot of waterfall processes being used in companies like this. In summary, though, I want you to understand as a learner that each methodology kind of has its place in the world, and we need to choose the appropriate methodology based on the organization and the project we're trying to accomplish. In this course, we're going to take the role of a business analyst, sometimes abbreviated as a BA. Now, sometimes you'll also hear the term systems analyst, otherwise abbreviated as SA. For the purposes of this course, we'll treat the two roles as being one and the same. Some organizations often will have minor distinctions or nuances between the two roles, but for the purposes of this course, the business analyst and the systems analyst perform similar functions. In this video, we'll take a short look at the role of the business analyst in information systems projects. After this video, you'll be able to describe that role as well as identify the phases of the SDLC in which the BA contributes, as well as explain the nature and extent of the BA's contributions in each SDLC phase. Let's first start with the role of the BA itself. The BA typically brings in, or business analyst typically brings in, a set of skills. Some of those skills were acquired in school through courses such as this one, and some of those skills were acquired on the job through experience. The primary role of the business analyst is to manage and mediate communication. So in my classes, I usually teach that the purpose of everything we do as a business analyst is really communication. When we document requirements, it's because we're trying to communicate those requirements effectively to developers. When we document a plan, we're trying to communicate that plan both to the people who have to implement it as well as to management. And so the central purpose for everything that the BA does is really about communication. BAs come from a wide range of educational backgrounds. Many of them come with MIS, Management Information Systems degrees from business schools. They could also be computer science graduates who find that they enjoy working with the business a little bit more than simply writing code, for example. And there's also a lot of people who come into the BA role as what are called subject matter experts. So, for example, I began my career with a local company that's big in the grain business, and many of the business analysts were actually former grain traders who found out that they had an aptitude for information systems, and so they started to become business analysts and learn how to document requirements and perform the functions of a BA. So I ask you rhetorically, if you were writing a job posting for a BA, what are the top requirements that you would look for? The BA contributes in all phases of the systems development lifecycle. We typically think of the BA's strongest contributions being in the analyze or analysis phase, and there is some truth to that. However, it's important to note that the BA's job is not done when analysis phase concludes. It's also important to understand that the business analyst should be involved in the project from the very beginning. There's no need to wait, for example, until plan phase is complete to bring the business analysts on board. In the plan phase, the BA is often performing important roles related to analysis of the project from a feasibility standpoint, something we'll discuss in a future lesson. In the analyze phase, this is typically where most of the BA's classic deliverables come in. You might have requirements documents as well as various diagrams that document system processes, whether they be the current processes, which we'll talk about kind of the as-is process, as well as the to-be or the improved processes. It's important that the BAs remain with the project past the analysis phase and into the design phase, because they're often a good reference or resource for the software developers or implementers to check their work and make sure that they're following the requirements accordingly and all the way through the implementation phase. Business analysts typically have been involved in change management or organizational readiness activities, and it's important that they remain with the project into the implementation phase so that they can see those through. Another way to look at this is that the BA bridges the gap of understanding between the business needs of the organization and the technology. The BA is, in a sense, a translator from the business world into the software developers or implementers who need to write or configure the software. If you graduate from school or you take a course like this one, you're typically going to want to skip the plan, analyze, and design and move right to implement. So this is typically, the information systems professional. If someone approaches them and say, hey, I need to automate my point of sale system, they kind of immediately begin doing research and maybe downloading and trialing some software, essentially blowing through the plan, analyze, and design phases and skipping right into implement. And that's if you have a computer science or an MIS background and you kind of get your energy from doing the implementation part of the project. On the other hand, if you don't have that kind of an aptitude, then you might be tempted to hand it over after the plan phase, and this is also not the best approach. So you might be tempted to cast a high-level plan and then hand it over to, for example, MIS majors or computer science majors who can then take the project and run with it. But a good BA is involved in all phases, with the strongest contributions coming during the analyze or analysis phase. As we move through this course, we'll take an in-depth look at the BA's deliverables in the plan phase, analyze phase, and design phase. We'll spend most of our time in the analyze or analysis phase looking at the types of deliverables that business analysts typically deliver in that phase.